And welcome, viewers, to the Daily Space Weather Show. It's been a tiring day. We've got some limited imagery of the sun. Those are 24-hour videos from SDO. And, so far, space weather impacts have been a lot less significant than expected, I'll say. Some more imagery from SDO. And we were expecting all kinds of geomagnetic storms and things, so... Anyway, by the way, if you haven't checked out the homepage, check it out, smashomash.com. Hey, look there's Jaws, our new thumbnail, from our power outage footage. Let's check briefly what's going on as far as volcanoes goes. As far as volcanoes go, that's how it works. Grammar. It's a thing. So, the Reykjanes Peninsula volcano near Grindavik has once again stopped erupting. The ground is still deformed there, and there are a lot of volcanoes going off, like Abiko, Suwanosejima, Luatobe, Semeru, Merapi. A new one I've never heard of on the list coming up here. Also Dakono, White Island, New Zealand. They're north of the New Zealand North Island. Garaloy and the Aleutians, Popocatépetl, Santiaguido, Fuego, and Sangay. And don't forget Revenador, Sabancaya, and Villarrica. So yeah, quite a lot of volcanoes indeed. Next we'll cover earthquakes. And what is the earthquake scenario? There are the past 90 days, and we're seeing an earthquake drought here. So a drought of large quakes, which means a large quake is imminent. Here are the past 24 hours. Philippines had a 5.0. Is that the foreshock preceding the next 7 magnitude earthquake? Let us know in the comments what you think. And don't forget to press the like button, lest thy soul be cast into an ever-deepening and darkening abyss of doom, destruction, and doo-doo diarrhea. Next, Papua New Guinea had a 5.1. That was at 1913 Universal Time this evening, so it's been quite quiet here, quite quiet indeed. Maybe too quiet for your own good. Let's get into some space weather stats. The 10.7 centimeter radial flux is now at 195 solar flux units. 195 is the 10.7 centimeter radial flux. There you can see it almost reached the highest level throughout solar cycle 25 period. So it's gotten to 209 recently here, I think, it looks like. And the highest we saw throughout the entire cycle was only like 212. So almost reached a new peak, and you can notice that you can see those spikes there, especially over way on the right side of that graph. The spikes are getting larger, and that's what you can expect to see. A larger range of sunspot number for that red line and the black line. So that's what you see at solar maximum. You see sunspots at all active latitudes, as well as a large variation of sunspot number, dropping way down to 80 sunspots and way back up to 200 and so on in a matter of a couple of days. That is a normal thing at solar maximum. So also, if you don't follow us on Twitter, perhaps you should. You might see this post, which we shared last night, courtesy Bob Lehman, one of the authors of the Terminator hypothesis, that the sun's magnetic fields cancel each other out for a while, and eventually that leads to sort of almost like a buildup of magnetohydrodynamic pressure, which leads to actually more sunspots. So it's a way of forecasting more activity, sort of literally resulting from less activity as the magnetic fields cancel each other out when they're very equal to each other. But that doesn't mean the sun's shutting down. It means that the sun is really ramping up, ultimately, to have additional outbursts. Also, Bob is forecasting the increase of the X-ray flux here for the next, 14 months, something like that. So, what this tweet is stating is that oddly numbered solar cycles have a tendency to produce their largest flares on the downswing. So after solar maximum, the largest flares are statistically most likely. Let's move on to our space weather enthusiast dashboard here. NOAA's forecasts for space weather indeed include continued geomagnetic storm conditions, although we ain't got none so far. So So far, the CME impacts have not been really materializing, but what can you do? There you go. Expecting CME impacts basically at any moment. In fact, they're showing up a little late here, so perhaps that ejecta was moving a little bit more slowly than anybody forecasted, including us and NOAA. I'm not sure what any other space weather channels, like mainly Tamitha Skov. I'd be interested in knowing what Tamitha Skov forecasted. If anybody knows, let us know in the comments. And so here's NOAA's forecast. That's NOAA's Enlil spiral. And you can see we're already overdue for multiple CME impacts. So again, they could be arriving at any moment. Here's Earth's magnetic moment from space for the past 4 hours, and again, it's geomagnetically calm, so no big space weather impacts showing up. So again, that ejecta likely moving a little bit more slowly than anybody anticipated, including me. So of course, part of the reason we do space weather is because I realized that there were additional challenges. Regular Earth weather is way too easy to forecast with all the data that we have. So space weather was the next obvious challenge as far as nature forecasting. There are the past 4 hours of Earth's magnetic moment from the ground. Our ground magnetic perturbations map. Geomagnetically calm, there may be some aurora kicking up tonight. But at the moment, we haven't even made it to KP4 in the past 24 hours. So KP 3.67 is the highest we got. Again, likely space weather impacts are imminent. We've got, 4 more CMEs on the way at the moment. So we should see 4 more distinct CME impacts, assuming they don't cannibalize each other and eliminate each other's signals. So anyway, that KP2 is the current situation. Here's a real-time solar wind from ACE and Discover. So there's ACE. Finally seeing a density increase at ACE, so about 7.25 protons per cubic centimeter, and solar wind velocity here about 416 kilometers a second. Discover showing similar data there, about 7.25 protons per cubic centimeter and about 418 kilometers per second. So pretty consistent data there. We should see some obvious spikes in this when we see CME impacts. Only little perturbations in the map there, so no major changes to solar wind despite multiple likely events on their way to strike Earth. GOES magnetometer remains in a very tight range here, seeing higher lows and lower highs. Next, our top view ecliptic plane field plot. Gotta love it. It's so good. And Earth is in a North Pole heliospheric sector, I believe. Indeed, and we will remain there for another day or two, assuming the magnetic environment doesn't suddenly change, which it is able to do. Anyway, here's our line of sight field plot. Probably the most definitive 4 days of data you could possibly look at about the current state of affairs. It shows the photosphere magnetism, the solar B field, and the polar fields all at once. And if you're unsure which is which, leave a comment, and our viewers will probably fill you in if we don't do it ourselves. We read all comments on the channel. Here's our line of sight coronal hole plot, and North Pole coronal holes with some South Pole ones rotating in. Oh, and being canceled out. So there you go. That's a Terminator-like event right there happening in the east. You can see that magnetic tug of war happening right up in this area. Just watch right up here. I'm going to put an arrow here for you to make it real easy. Right in this area. You're going to see South Pole coronal holes suddenly get canceled out by North Pole coronal holes. So that is a magnetic tug of war happening. So that is an area of volatility, the northeastern limb. Just in the past 2 days, that's happened. And let's take a look at coronal holes from SDO. So there you go. There's 211 angstroms. So eyes on that northeastern limb. So that's a new spot to see new sunspots likely to grow as a result of the data we just showed you. And let's move on to sunspots now that we've looked at coronal holes and those other features that we've looked at. Sunspots are next. Sunspot number has now dipped below 150. It's down at 134. 134 is the sunspot number. And here's our synoptic map. Likelihood of X-class flares has dropped. Also M-class flares. So we still do have some flare risks, though. Here is the flare probability monitor and scoreboard maps. And what do you got? We've got degradation. So, yeah, sunspots have been diminishing since yesterday, both in complexity and umbral space. Here are SDO's sunspot images. There's 171 plus continuum. And we'll subtract the 171. There's just continuum. That's what about 145 sunspots looks like. 135? Whatever the number is. I don't care. I literally don't care. Because I'm not involved in any sort of a dogmatic and ridiculous practice about, painting myself in a corner and saying, ooh, the sun's shutting down, ooh, space is spooky, ooh, 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 and all of those ridiculous things that YouTube channels do. And of course, when you see our alarmist thumbnails and titles, it's literally satire of those content creators. Anyway, so the proton event does continue. We still do have significant polar radio blackouts and brownouts. Large sections of the frequency range there completely blacked out over the southern polar region and indeed the northern polar region, as you can see there on the map. The D region of the ionosphere is being attenuated by solar proton events ionizing portions of the Earth's atmosphere. It's a proton event, or solar energetic particle event, and there is the GOES proton flux as measured in the geosynchronous near equatorial orbits of the GOES 18. Just the GOES 18 now. So you can see spikes in all three different energy levels, now subsiding back toward the warning threshold, which when you see that, then you're going to see some of those polar radio blackouts turn to brownouts. And let's take a look at flares next. There we go. There are flares. There's flares. And it's been a lot calmer in the past 24 hours. So anyway, we'll look at flares from SDO. There's 94 and 131. Great wavelengths for flare viewing, but not a lot of activity for the past 24 hours. Next, a star chart. That's what's going on overhead us. Crescent moon up there, also Jupiter and Saturn. Next, a solar system forecast. Things today. Things in 1 week. Gibbous waxing moon, as Earth is in a lonely side of the solar system. Look at that. 0 planets on this side of the sun. 0. All the planets are on the opposite side. If you're feeling lonely on a planetary scale, well, maybe that's why. It's hopefully not. Next, our astronomy photo of the day, which is a wolf moon by Andrew Zakarsky. And here it is. Here is the lovely image of Earth's satellite. There you have it. The wolf moon. Why? Because it looks like it's being bitten by wolves or something. It's like, see, it's a big wolf mouth right there. See, there you go. Or it's Pac-Man. There you go. Or something. apod.nasa.gov if you want to check it out yourself. Coronal mass ejections are next. So here you go. And it's only 40 frames. Let's move on. That's not a lot of information. And that's lacking too. So as far as this goes, it's been pretty chill for CMEs for the past 24 hours. Let's switch to our custom coronagraphs. So actually right around midnight once again, another CME. And is it earthly directed, you're wondering? I certainly am. And the answer is, I don't think so. Hard to say, though. The timing is less than optimal. I don't think it's earthly directed. I think it's on the far side. So that's my story. I'm sticking to it. And let's move to filaments. There's 304 plus 193. Here are filaments. Oh, first the stereo A imagery. Don't forget that. That's pretty good. And yes, that indeed does not look earthly directed. So we still do have 4 CMEs on the way that are likely earthly directed, though. So we're waiting for those. They're a little bit late, moving a little bit more slowly than we anticipated. So here are filaments from Cerro Tololo, Chile. Cerro Tololo, Chile. And here's our colored images. This filament right here, I think I meant to name that one yesterday, and I never got around to it. I really ought to, but these ones could use names as well. This one here, this one here, this one down here. All majorly large and dense plasma filaments on the Earth's side of the solar disk. The kind of things that end up as coronal mass ejections, folks. We'll close out the space weather section with the last couple of hours from the GOES 16 SUVI. Crown prominence is there all over the northern polar region, not so much at the southern polar region. And let's conclude space weather and move on to meteorology. So, bonus features, satellite charging hazards, we ain't got none. It's smooth sailing. Only minor surface charging there over the northern Indian Ocean. Nothing to really concern yourself with very much at all. Not going to cause communications breakdowns or anything. The GOES electron flux there kind of low. There's the 1-year graph of the electron flux. The greater than 2 mega electron volt electron fluence. There is the forecast model. The green boxes are the forecast. The yellow diamonds are the observation. And the geomagnetic storm never hit as expected, so it didn't get as low as we thought it would. So see yesterday's video for space weather about that forecast. We expected it lower than it was, but it wasn't because CME impact did not really happen yet. But it will drop when the CME impacts do begin occurring. Next, we'll show the ionosphere, the layer of the atmosphere where that is measured. The ionosphere, folks. Here it is in vibrational frequency. So that's what's going on at about 300 kilometers of altitude. Not a lot. Space weather has been a dud so far. There's the anomalygram, and we expected to see a lot more red on this than we're seeing. So that's anomaly in megahertz from a 30-day median. Not so exciting. Space weather storms not so arriving as expected. Next, the WAM, the whole atmosphere model. And that's a thing. And here's the last thing for the space weather section of the video. It's the latest imagery. So there you go. Not too exciting. Let's briefly look up here. And is there a new sunspot rising? I think there is. I see a little bit of deformity there. So I think there is a new sunspot rising in the northeast. It could be a gargantuan monster. And just a quick reminder, folks, never try to sneak up on a dragon in its lair. Now, it is the year of the dragon, so it's probably a good idea to know what goes on with dragons. So, just saying, don't try to sneak up on a dragon in its lair. even if it doesn't have all kinds of traps set up for you, it's just intrinsically bad. And I'm not going to get into the gory details of why it's such a bad idea. It's just a bad idea. Don't try to sneak up on a dragon in its lair. It could be unhealthful. Next, looking at a low pressure zone. Of course, this is Cape Cod right here, so I'm kind of giving it away. See, there's Cape Cod. So, yeah, that low pressure is the one that caused the northeast in the northeast. The nor'easter, rather, in the northeast. So there it is. There's that low pressure. That's sea level pressure and surface winds. Yes, sea level pressures and surface winds, you see. You see. That's what you see. And here are the rest of the planet's wind patterns. There are surface winds for the east and the jet streams. Don't forget the jet streams from Europe, Africa, and the Middle East. There you go. Surface winds for y'all. Surface winds for the Western world. And our jet streams. By the way, power outage maps are nice. This one is poweroutage.us. And we had a power outage that lasted almost exactly 4 hours today. 85,000 custies still out of power in Pennsylvania. Also another 27,000 custies in Massachusetts. Next, clouds and fog over the U.S. and South America, the Americas. As this atmospheric creek continues to send moisture from the Pacific Ocean all the way to the Atlantic Ocean. It's a transcontinental pipeline, a watery pipeline. So here's that low that's now out in the Atlantic. It brought all that moisture all the way across Texas and into New England and beyond. Now headed its way up toward Newfoundland, and then eventually Iceland and Greenland. So there's that low. You can see this classic counterclockwise rotation. And here is our snowfall map. So there's our snow depth map from windy.com. Windy.com, snow depth. Next, weather.gov. Yeah, that's right. The National Weather Service homepage. Where to get your weather warnings if you're at, I don't know, whatever. Whatever, there's your weather. We've scrolled down to show you the key. We're not going to do much more than that. There are too many counties lit. A bunch of waterways cresting there in the southeastern U.S. As you can see, some assorted flood issues happening there. Here's our one forecast for the day. Yeah, only one forecast for the day, folks. It's pressure and precipitation GFS 72 hour. That's all you get because I am fatigued. Fatigued. Next, a lightning map from lightningmaps.org. But first, the last 10 hours of lightning, and it's pretty calm here. But we did see some lightning activity off the coast of Cyprus. Since then, things have calmed down. All right, there we do have some strikes. Some strikes in the eastern Mediterranean there, off the western coast of Cyprus. So quite a severe thunderstorm there. Perhaps some good surf on the coast of Cyprus. And let us know if you've gone to Cyprus and stayed at Eric Schmidt's place. Eric Schmidt. You know, the founder of Alphabet. Maybe you've heard of him. Anyway, here is our U.S. Doppler radar map. Yeah, Eric Schmidt. He lives in Cyprus. He's built a bunker in Cyprus. Lake effect snow rolling in to the northeast. Clouds and fog. And don't forget water vapor, as cold air is moving in as well. Cold air there bringing in lake effect snow. So here's the recap. U.S. Doppler radar showing vertical motion in the air column, space-based systems showing 3.9 micrometer infrared radiation, and space-based systems showing water vapor, as in all of it, 6.61 micrometer infrared radiation. And here's me signing off and thanking you for joining us at the Smash News Network, least busted name in news. And until next time, tomorrow, may that solar wind be at your back.